All right. All right, let's have a look at number one here. We've got three inequalities to look at. And as you can see, the first two are not in slope-intercept form. So I'm going to go ahead and rewrite those into slope-intercept form. This is a special case here where we have x is greater than 0. We don't need to do anything there. We'll just go ahead and graph that. Notice I have these color-coded. So I'm going to start with rewriting the first inequality into slope-intercept form. So what I need to do is, well, I'll just write it here. 2x minus 3y is less than or equal to 12. So I want to isolate y here. I'm going to subtract 2x from both sides, so that gets us a little closer to where we want to be. When I do that, I have negative 3y less than or equal to, and since I subtracted 2x, minus 2x plus 12. Now we need to isolate y by undoing this multiplication. So we're going to divide everything by negative 3. Now, when we do that, we change this from a negative to a positive, and therefore we have to change the direction of this inequality sign. So I'm going to divide everything by negative 3. I'll have y, and since I'm dividing by a negative, I'm going to change the sign. That will change what it's shaded too, so that's very important. And it's going to be negative 2 over negative 3, the slope, so that's negative divided by a negative is positive 2/3 x, and 12 divided by negative 3 is minus 4. So now we have this one is written in slope-intercept form, and I could graph that. Let's just also get the other inequality ready. Okay, so this is the black one. I'm going to change this to green. So the other inequality, x plus 5y is less than or equal to 20. So again, we need to isolate y. So we're going to start by subtracting x to both sides. So 5y is less than or equal to negative x plus 20. And then to undo the multiplication, we're going to divide everything by 5. So y, and we don't change the sign here because we're dividing by a positive. Y is less than or equal to negative 1/5 x plus 4. So now we have our starting point here, and we have our slope. Okay, so I can go ahead and graph these. Okay, so let's just take a look. I should actually change my key. This one here should have been green, so I'll just change that. This one's going to be red. Change this one to green. All right, let's start with graphing the first one. So our starting point is at, okay, negative 4. So 1, 2, 3, negative 4. That's our starting point. It is a positive slope. So the rise over run is 2 over 3. So 1, 2, and then the run is 1, 2, 3. Okay. So our slope is positive. And then if we go back and look, this is equal to, it also includes the line. So we're going to make sure that it's a solid line. Let's go back and graph that. It's a solid line. Okay. Forgive me for having a line that's not so straight. Okay. And then also when we go back and look at that again, we can see that since y is greater than, we are going to shade above the line. So I'm just going to actually not going to shade too far. So you can see when we overlap, it doesn't get too crazy. Okay. So there's our first inequality. Let's take a look at the other one that we isolated. Our starting point here is at 4. So I can go ahead and find that, which is right here. The slope is going to be negative, and the rise over run is, so down 1 and then over 5. So actually going to be here, right? Sorry. Down 1 over 5 gets me out to about here. Okay, this one is going to be, it's a very shallow slope, okay? So it comes across like that, okay? Again, it's a solid line because it includes the line, but this time it's less than, y is less than, so we're going to shade below the line, okay? So we can see so far this is the region, here that should be shaded, but we have one more inequality to look at, and since we have x is greater than 0, okay, that is a vertical line. So x is always greater than 0, and it's not including the line. So I'm just going to put a dashed line. It's actually, it is on the y-axis, okay? And since it's greater than, we're going to shade to the right of the line. So that's going to be this area right here, okay? So then in the end, the feasible region that we should be shading here is this triangle here, okay? Now, if we go and test a point in here, for example, if I go and test 1, 0, it's going to satisfy all of the original inequalities back here where we started. If it doesn't, then probably you made a mistake at some point.